Let me begin. Thank you, Bruno, for your introduction. Yes, I have been a teacher for a while, a few years, I think. I've taught at Dawson College in Montreal for over 30 years. So that's been exciting. I'm just taking a moment to move things around. There we go.
Yeah, so we can see your screen now. So
you
so
should be able
fine.
to see the screen. If we go to full screen, are we okay?
Yeah, we're okay. Okay, we see your full screen.
Cool,
and now just
cool.
just make sure that on the chat you are on the stage chat so you can see people commenting.
Yes, that's where I am on my second screen. So if anybody sees me turn my head, it's because I'm looking to see if there's any comments. So thank you all for spending some time. For me, it's in the evening. For you, it's sometime around the world. And what I want to talk about tonight is the place of Java in education. I've been a teacher now, as I've said, for 30 years. In that 30 years, I've been teaching Java as a primary language for the last 20 years. I teach in a program that's, well, we're not a high school. We're not quite a university. We're more akin to a community college. Here in Quebec, students come to a community college for 2 years between grade 11 in high school and starting undergraduate studies in a university. But these community colleges are also the home of technologies or careers. So if you wanted to be a nurse, you would come to Dawson College. If you wanted to be a recreation technician, you would come to Dawson College. A graphic artist. There are 22 different programs. And at Dawson College, computer science is a 3-year career in which our mandate is to train our students so that they can be productive on the first day on the job. And over our years of experience and our working closely with industry partners who hire our students, at least I have developed what I think is a good sense of the path people should follow in education if their career goal, if their career goal is to be a professional programmer. And that's what we're going to talk about now. So I call this presentation Java in Education, sometimes Renewing Java in Education. What I hope to do is take a look at some of the recent enhancements to the Java language that have made Java even more relevant than ever in education. And I know this might sound strange, but at every level, whether it's elementary, secondary, college, university. These enhancements certainly dispel a lot of the myths, and I thought it might also be worthwhile doing a little comparison, and I want to stress it is a little comparison with Python, that scrappy little language, which I believe every programmer should learn after they've learned Java. So what are some of the downsides that we frequently hear when people are discussing Java? My favorite, of course, is it has a steep learning curve for a beginner. Well, programming in any language is a steep learning curve. And more often than not, the people who claim this are people who struggled when they first approached the language. I don't think Java is any harder or any easier than any other language. Another popular myth or downside that people talk about is that Java is not suitable for those lightweight, those quick and dirty tasks. It's really designed for the big enterprise industrial tasks. Well, one of the things I'm going to show you this evening is single file source code. If you're a Linux user, although I cannot demonstrate that because I must admit, I'm a Windows guy. The shebang feature for Java is amazing, putting Java up there with shell scripting. And then, of course, the third and one of the most common myths, one that I have fought greatly even within my own department, is that Java, for some reason, isn't open source, that there's going to be money required to use it. And of course, that's absolutely false. If anything, there are now more companies than ever supporting Java because it's open source. The OpenJDK is the open source implementation. And all those amazing developers who work at Oracle contributing and advancing, enhancing Java, well, they're all working first on the OpenJDK version. I came across this, and I don't expect you to spend time reading this whole long piece, but it's from a little over a year ago, and it is a perfect example of myth, right? I've highlighted some of the key points: that too verbose for beginners, need to have knowledge of classes, static methods, and packages. I think the most bizarre line in this particular paragraph from the Software Development Times is that C is easier, or even more bizarre is that Python, this is just a one-liner. This particular author went on to predict that by now, Java would have faded away and we'd all be Python programmers. Here's the July 2020 index. Java, which typically is in the top 3 and has been pretty much from day one, has slipped a bit behind C. But look at Python. If anything, Python's losing ground. Python is an important language. It's just not the first one you should learn or should be teaching. So, what are the benefits of learning Java, making that your first language? Well, we always like to say that, oh, Java is an old language, but notice that Python is from 1991. What is really important is that line that says more programmers than any other type of programmer in the world. There are, well, on a good day, 12 to 13 million people developing code in Java. Now, I can't tell you, is that more than C++? Is it more than Python? I really don't know, but that's not important. At some point, when there is such a critical mass of developers as there are for Java, you know that there is an amazing community that wants to share with you, that wants to mentor you, that wants to make you successful. And I think that's one of Java's greatest strengths. We know that Java derives its syntax from C, as did C++. And quite frankly, well, as someone who had the misfortune of spending some time coding in PL1, I'll tell you that C is derived very much from PL1 in some respects. But the fact is that Java sits at what I consider to be the sweet spot. It employs a number of concepts from older languages like C. It introduced new concepts, which in turn were copied in other languages. As I say here, you want to learn Java first. And then you have a whole group, whole family of other languages waiting for you, which will be far easier to learn if you started with Java. And of course, let's not forget that when we say Java, we also mean the Java virtual machine. There are a whole range of languages. I mentioned Kotlin here, which is popular in Android development, but it's not the only one. That virtual machine is the real marvel of Java. So let's take a look at the first feature that I think is significant in using Java in the education space almost at any level. And that's, of course, JShell, or sometimes called read, evaluate, print loop. This first became an official part of Java at JDK 9. There were versions of it in different types of tools over the years, but at JDK 9, it became official. What JShell allows you to do is introduce Java in such a way that even with the minimum facilities of a computer, you can use the language. So here, let me show you. I'm just going to leave my PowerPoint for a moment and open up one of my command windows. So here you can see, bring this closer. Here you can see my J shell window, right? I called up a command window in Windows, and this would be almost the same if we were working in Linux or on a Mac. I issue the command J shell, and now I get the J shell prompt. Here I can type in any line of code. And again, I'm assuming you've all seen this, so I don't think I'm really showing you anything new. Whoops, I like 4. And now I can say system and let's put in my X. And no surprise there, it printed out 4. So that's easy. But I don't know if you're aware of another really cool feature. Let's imagine a teaching environment where you're using an editor. Maybe you're using Windows Notepad. Maybe you're using a basic editor in a Linux or a Mac environment. You've prepared your code, and now you'd like to run it. So I'm going to type in /edit, which will open up this nice little window. And what it allows me to do is to examine what's already been entered into the system. I can add to it. I can edit it here. I can do whatever I want. Now, I want to start fresh for a quick example. So I'm just going to exit from here, and I'm going to say reset. Let's clear the environment. Let's edit again. Here we go. There's my edit. Now, let's pop over to my text editor. So what we're looking at here, and let me find the right file. Here we go. Here's a little bit of code in Java. Its purpose is to calculate monthly payments for a loan. So I've created this as a method. Notice there's no package statement. There's not even a class statement. I've moved right into writing a method. I could have actually just entered those lines of code without even the public void loan, one at a time, and the application would have worked. But let's start with a method. So I'm going to grab this method from my basic text editor. I'm going to go back to my JPad, and I'm going to paste it in here. Let's bring my J shell behind it. There we are. So we're all set. Let's accept what I've written, and we can see the message here that it's created a loan. We can exit, and now all I have to type is loan. And there we go. $5,000 at 5% interest for 5 years. Oops, I'm sorry. I have to remember this in months. So that's 60 months. I should have fixed that in the code. Enter years multiplied by 12. And there's my answer. So there we have, we've interacted with Java code. Let's look at that again. Sorry, it's a little small here. I don't know how well you can see it on your screen. So if I go back to my editor, I've able to use this code, teach students about it, apply it without all those verbose decorations that the myth about Java discusses. There we go. Next is a feature that joined Java at JDK 11, and that is launching single file source code. You know, of all the things that have been added to Java, and there have been some really cool things, we'll see them in the next slide or two. Excuse me. This is the one that I think is the most significant from the perspective of education. Too often there is the myth that it's necessary to use a heavy IDE, whether it's Eclipse, whether it's IntelliJ, whether it's NetBeans. But with single file source code, you can, for the first time, write Java applications. There can be as many classes as you want. The only requirement is they must be in a single file. Now, with all your code in a single file, it's simply a one-step execution. There's no compile, there's no package, there's no execute. It's just good old Java. Well, let's take a quick look at that. I'm just going to jump to my next slide. I'll go back. We'll come back to that one in a moment. Let's leave here and go to a second window. So here I am. I'm at a command prompt. No J shell, no funny business up my sleeve. I want to execute a complete Java program in a single file. So let's take a look at calculator 03. So here we have the calculator we just ran in a single method turned into a simple class. We have my input data. We have my process data, my output result. For those of you who may have an old mainframe background, there's the old input, process, and output. And then my perform to actually do the work. And if you attended my session this afternoon, here we have what I would consider, well, the near perfect main. I see one enhancement because we all hate typing. Why don't I just make this var? There we go. Now I've simplified it to the current standards. So I want to execute this file. Save it up because this is the file we're going to execute. So I'm going to copy here the command line. And you can see it says Java. Now the next two switches, source 14, enable preview. If I were not using preview features in Java 14, I wouldn't even need these two switches. I could just say Java and the program. What am I using new? I'm using a record here. So I needed this little bit of extra help. I look forward to when I don't have to. So let's go back to that command line. And let's paste in the command. So there we go. My expectation and what I want from this is my program will compile and will execute. And here we go. Another $5,000 at 5% annual percentage rate, 60 months, and I've got my answer. With single file execution, you're able to teach Java, again, with just a simple text editor, without the overhead of IDEs. Oops, there we go. So this is something I mentioned briefly before, and this was also part of single file source code. Sadly, it only works on Linux. I really hope there's somebody over at Oracle desperately trying to figure out how to make this work in either PowerShell or command. What we're doing here and taking advantage of a feature of Linux is to define the executable needed to actually run this script. So this particular syntax I've seen in other different languages. So here's my little Java program. Of course, all it's doing is hello JavaScripts, but it could be maybe renaming every file in a directory, downloading code from a Git repository. I cannot think of anything that you'd use a bash shell for that you couldn't use a JavaScript for. In this case, a Java language script. So, a couple simple steps, and then to execute it in my Linux environment, I can use the same syntax as a shell script. I think this is really cool. And again, something else that restores Java to a significant place in systems management. Let's look at some of the new features. And we saw this one briefly when I edited my sample code. var. Yes, Java was excessively verbose. Just look at that declaration. My class M equals new my class. Why the heck do we have to say my class twice? The compiler will spot that the type is on the right next to the parentheses. So it's obvious that the type on the left has to be the same. Well, now it is. We have the new keyword var. If we use var, we are also required, as you can imagine, to initially instantiate the object that we want var to represent. We know that we can declare a reference, then forget to use new, and then later on in the code meet our most famous exception, the null pointer exception. It's always a little unusual when I'm teaching a very beginner's class. Or actually, that's maybe not a good example. A better example is when you're training programmers who are moving from the world of C and C++ to Java. And you tell these C and C++ programmers, "Ooh, Java's really cool. There's no pointers, only references." And everybody in the class goes, "Ooh." And then a few minutes later, somebody puts up their hand and says, "How come I got a null pointer exception? Didn't you say there were no pointers?" Well, I'm still trying to get an answer from Oracle on that one. Or if you worked at Sun, maybe you can answer that question, why it doesn't say null reference exception. But whatever. When we use var, we have to instantiate the object. One less opportunity to get a null pointer exception. Text blocks. Trying to place text into a Java source file and maintain spacing has always been awkward. When we have to create strings in specific formats, whether it's HTML, XML, and JSON, it would really be cool if we could express them exactly as their proper formatting is. Well, we finally can. And we do that with 3 quotation marks in a row. So here's a perfect example of how we might create an HTML file inside of a string. Nothing special here. There's the usual plus, 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 plus. I actually noticed the other day that my IDE would handle all of this for me. But it still doesn't give me the sense of what was its original style. I cannot, for instance, capture a text file with its indents, with its spaces, and use it directly. Or at least I couldn't. Now, here is exactly the same text. Notice the 3 quotation marks at the beginning and at the end. Now, when I'm looking at my source code, if I have to explain to students, especially if I'm doing server-side programming, look, that's exactly what I want. There is my formatted HTML file. The switch. Boy, talk about something that just couldn't get enhanced. You know, my first experience, of course, with the switch as we've known it was in C. And then C++ came along and the message was, you know, that switch in C was good enough. Okay. And then Java came along and the message in Java was, that old C switch is good enough. It never was. I'm going to say something sacrilegious. The best switch statement in any language was in Visual Basic 6. Boy, you could put anything in the case. It was glorious. It was so much nicer than if. Well, we may not be there yet. We may not have achieved the quality of switch that I had about, close to 20 years ago. but we're certainly getting a lot closer, and certainly better than we find in other languages. We finally have a switch that we can explain, that people will understand. It reduces the amount of duplication that frequently happens in a switch when we keep having to assign a value to the same variable case after case after case. We now actually have 3 switch syntax forms. There is the original switch with our case and our breaks all over the place. There are switch expressions and there are switch rules. And in the case of exceptions and rules, it is the end of break. They all terminate. Finally, that really bad example of showing a switch where we use the numbers for the days of the week to distinguish between weekdays and weekends. We can finally stop using that, lame example. Well, let's take a look at a new switch. Here we get to see the side by side. On the left, we have a traditional, as I will call it, switch, whose purpose is to assign a value based on whatever the numeric value of point is. So we've all been using this long enough, so it all makes perfect sense to us. But it contains the kind of thing that drives me crazy when I'm looking at code anywhere, and that is redundancy, repetition. Look at how many times we see the code value equals, how many times we see the word break. When people hold this up and start talking about how Java is verbose, it's hard to argue. On the other hand, the syntax on the left is still what C and C++ want to do. I haven't looked at C# lately. I'm hoping they've updated. But look on the right. What we've created now is called a switch expression. As an expression, notice we introduce a new operator, the dash and the greater than, sometimes called the right arrow operator. And now the compiler recognizes that if I show a value after a case, then that's the value that the switch should return. And there's a new concept. A switch expression can return a value. You can see it is significantly smaller. I love these new switches, and I think they will make Java much easier to teach. Records. We've known for some time that the source of many problems, especially in sophisticated code, is the issue of mutability. The fact that side effects that involve changing values, improper use of setters, for instance, can be the root of many problems. And that our goal is to create or to have immutable variables, objects. The record is the first, and well, maybe someone can correct me, I'll look at the comments, but the record is the first immutable class type in Java. It allows us to simply, and take the place, some of you may be familiar with Lombok, take the place of Lombok and allow us to create objects in a simple manner. And as a bonus, there's this compact constructor, which I didn't learn about until I did the research for this, and I thought that was really cool. So here we go. Here's an example of what a record would look like. Notice that after the record name, we list the variables that are going to be the members, the instance variables of this class. That Java will will recognize that any of these objects are part of this class, that we don't need a separate list. Because it is immutable, we know that we must provide these values when the object is created. There is no equivalent of a setter in a record, just the equivalent of getters. That kind of precludes the need for a constructor, except when validation is concerned. And so here you can see the compact constructor. And it really is compact, where I can examine one or more of the instance variables of this class. Oh, some people are asking about Lombok, I notice. Look it up. It is kind of cool, but I think records and coming enhancements may finally push it aside and make immutable part of the language. So we can see from this particular style that we now have, shall we say, a safer object. In my courses, I like to use the old Java bean specification as the, as I tell my students, the cardboard box into which their data flows, is held, is transferred from operation to operation. Of course, that means that there's all these worrisome setters. I guess I could leave them out, but it's still not truly immutable. The record introduces immutability, and I think this will become a very common aspect of programming going forward. When you see me turn my head, I'm just looking at the latest comments. So a couple people are talking about Lombok who weren't familiar with it. Look it up. It can be a great tool so you don't have to use your IDEs, setters, and getters. I can remember learning iOS programming and being fascinated with @synthesize, which would generate all of the boilerplate methods. Well, enough of that. What's pushing Java aside? Why is it no longer as significant, as widely used as it once was? Well, first of all, if we look at schools, there are a couple of issues. Let's take JavaScript. In the case of JavaScript, well, there's pretty much little to download. Every school's got a browser, and every modern browser can execute JavaScript. Even more is the fact that there are numerous online programming environments. You don't need an IDE. Heck, you don't even need a text editor. There are online sites that allow you to work and play with JavaScript right away. Then there's Python. Python has of late become very significant in the worlds of big data, artificial intelligence, machine language. I've always believed that that strong association is based on two items. Number one, many of the really amazing big data or AI libraries are written in C. Python is based on C in the extent that the Python runtime is all done in C, which means it interfaces with C libraries very easily. So if you are a developer, not a developer, say you're a researcher, you're a big data scientist, you do not need to learn formal programming to examine your data. With just a tiny bit of Python instruction and access to these amazing C-based libraries, you're all set to do machine learning or examine big data without really knowing anything about programming. Now, I think there's a place for when all you need to know is the answer. How you got there isn't important. But if you're writing software, if you're teaching people how to write software that's going to be used on the back end, the front end, day in and day out, I'm not sure if either of these languages are sufficient, though, well, JavaScript is the front end of most web, but certainly Python. I'm not quite sure if I'd really want my pacemaker programmed in Python. Anyways, I've still got a few years before I worry about that. little bit more about Python, because clearly when people talk about what should we be using in education, Python is the name that comes up more often than not. And I'll tell you why it's successful, in my humble opinion. I always feel strange reading out or saying out loud those abbreviations, IMHO. I think the problem with Python is that it encourages the stream of consciousness approach to coding. I should point out that JavaScript does as well. A stream of consciousness approach, as I describe it, is one in which the code is one single block. If we were thinking of Java, it would be the equivalent of writing a program and placing all the code in main. That when you look at programs, frequently you can actually track the thought of the developer. Oh, first they thought they're going to have to put something on the screen, then they're going to get a little input. Oh, now they're going to need a loop. That's what I call stream of consciousness. That thought, or giving thought to structure, isn't there to the same extent it is in whether it's C++, Java, heck, even C, C#. Python is just a let it go. And again, I've said there is a place for that, but I'm not sure if it makes the best choice for your first language. So let's compare on the next few slides some Java and some Python code. Now I'm going to tell you right up front, the Python code is more compact. And really for just a single reason I'll point out. But I think what you'll see is, for the most part, the two programs are really similar. And, well, I'm going to say which is easier for you to read, but that's unfair. If you've been writing Java all these years, the Python's going to look like a foreign language and vice versa. I think the most I can expect now in looking at Python versus Java is to demonstrate that actually neither language directly has an advantage over the other, but Java, because of its history in writing many types of systems that have been maintained over the years, it comes with a much better background for someone who wishes to learn to program. So this is again the borrowing money program. Let's take a look at how it goes. So here we go. Here's our basic Python. And yeah, you can see it's, well, quick and dirty, simple. There's no decoration. I have loan, I have interest, I have term, I have my calculations. Notice, of course, notice that because Python is not a strongly typed language, I think technically we say it's not typed at all, but I can't say that for certain. You can see us casting types to where we want them. Interesting problem. Interesting what would happen if I typed in Bob when it asked me for my loan input. Also, I would like to point out, let's see if you can see my pointer here, that Java does have something that I sorely miss, Python has something that I sorely miss in Java, and that is a command line input routine. We know we have scanner that also includes the output. So all told, we see 6 lines of code here. So here we go, the same code in Java properly dressed. In other words, we could argue that this would run in single file execution. It would also run if we were working it in JShell. So we can see some additions. We can't have any free floating code, so it has to be in a method. So here's my static. Notice here we have to have 2 lines, down here. We need the scanner, or we need the, the prompt, and then the input. Prompt and input, prompt and input. If we had a single input with prompt, we'd have 3 lines less. But when it comes time to doing the calculations, displaying the result, it's exactly the same. The only significant difference here is a little decoration up here and our 2 lines. Now, in that Software Development Times article, they talked about how you cannot teach Java until you explain, well, this is an import, or maybe I had a package statement. Ooh, I've got to explain what a class is. Ooh, I need to explain what static is. No, you don't. Not at all. How many of you still know how a carburetor works in your car? How fuel injection works? How the door lock works? You just use them and you focus on the skills you need to make the car go. Well, when I've worked with younger children, and watched children as young as 9, 10, 11, they just take it for granted. We tell them you've got to put that class thing there, they'll do it, right? I have always believed that people are intelligent enough to start with something that may seem complex and then fill in the information as it becomes necessary to change it. I don't really see anything. If anything, and again, I'm somewhat colored by my years of using Java, I think this is much clearer in making it apparent that this is an application. If we go back for a moment, to me, this is a script. But that's a personal thing. I don't want to get into an argument with anyone. Let's keep going. Let's jump now, actually, to the same code we used when I did a class. So, spent a bit more time learning about Python and learned how to create a class in Python. So now, of course, we have a bit of decoration that we didn't need before. My class, my def statements. And then finally, at the end, my worker equals and worker.func. It would be easy to make fun of the fact that Python is dependent on spacing for meaning, but then I tell all my students that they have to format their source code before they submit it, because I consider spacing important to understand what something is. So I'm not going to make fun of that part of Python. Let's look at the same code in Java. Actually, that was the code I ran in the single file. So yep, it appears to be significantly larger, but in reality, let's take a look. How about the closing brace? The tradition is they always get a line to themselves. I don't think we can say that this has made the code longer. And if it bothers you, just put it over here. Next, we have my input, and yes, we're kind of stuck with 2 lines for every input. But now when we come down to the process data, it is the same number of lines. And it's very clear that I will be using a value that's being passed in. My perform, my output results, these are all effectively the same. The only thing that made this larger was, in this case, the one import, the extra system.outs, and the closing brace. Otherwise, they're the same. Ooh, that record down here, one of the things that excited me about finding a record, and if we go back for a moment, the record now becomes the equivalent of this line of code in Python, which allows us to declare a tuple. Of course, the elements of the tuple are determined in the assignment, whereas over in Java, we define what the input is for this similar concept of a tuple. Tuple is also immutable in our record, loan record. This is something I recently added to this presentation because in my involvement in the Java community process, I've learned about this. It's the visual recognition JSR. And visual recognition is one of the significant tasks associated with machine learning, artificial intelligence. Amazon has now produced a Java-based library for visual recognition. Some amazing developers in North America, in Europe, Frank Greco, Zoran, have worked hard to create a standard API, a way in which from this standard API, we will be able to plug in any range of machine learning or artificial intelligence engines in the back end. To me, it's like having JDBC except for artificial intelligence. I think with Java's strength in the enterprise space, this has got to get the Python people a little nervous, I hope. I talked about this before briefly. Let's not forget that Java is more than just Java. It's about this amazing virtual machine where we have a family of languages: Kotlin, Scala, Groovy, Clojure. Heck, there's even something called Jython that if for some reason you want or you have Python code, but you want it to interact, with the JVM, possibly even use Java frameworks, it's possible. I'd still prefer to do it all in Java. So you've gone out and you've learned Java, whether it's university, college. Well, what kind of jobs are out there? Well, you probably know this already. Most financial institutions, at least here in Canada, I really can't talk about the rest of the world, but I suspect as much, depend on Java to run their back end. Companies like Twitter, LinkedIn, Amazon, everyone, including Microsoft, depends on Java every single day. Now, I can argue if you learn Java, you'll be a better programmer than somebody who learns Python. I think that's true, but you still have to be, well, you have to code well. And so I cannot tell you if you learn Java, you may get a better job than someone who learned Python. There are other factors here. What I want to say is that you learn Java first, that the principles and concepts that you learn in Java will put you in good stead when you move to JavaScript, when you go and do Rust, when you do Go, heck, go back to C and C++. It's the language you want to start with. It's the language that will give students a clear understanding of what it means to be a programmer. Now, this presentation was initially designed to go to JUGs to help them themselves reach out to schools. I know locally in Montreal, there is a slow move towards putting Python in CS1 classes. Make that the first language students learn. So these are some of the things that I've suggested to JUGs that they can do to, well, possibly encourage their local university to rethink what they're doing, whether it's having special meetings for faculty, organizing hackathons, getting involved in the different associations. There's a lot of different things that we can do, right? You're all here as part of your career development. There's a lot to learn about a lot of languages, but I think Java is where you need to begin. Something I just came up with the other day, and that is Python is the second language everyone needs to learn after Java. If you'd like to see some of the sample code, if you'd like access to these slides, all of this work was produced under the Java community process. Therefore, everything is public, it's published. This is through my GitHub, but you can also find these slides through the websites that Heather talked about in the previous sessions. Thank you all for listening to me, and I look forward to any questions you may have. Here is a bit of a bibliography if you want to look at some of the things I've talked about today. So I'm going to stop sharing my screen. There we go. And I'm going to move over to here. And let's see what comments we have. Somebody's pointed out that Java is important in the New York City area. Konstantin has pointed out Grail VM. which is an amazing VM, again, to simplify what we do with Java. Now, somebody's asked me to talk about Jython. I would if I knew a lot about it. When I did my research in preparation of this, I had noticed that Jython has been a bit stagnant lately. You'll probably discover that when you find its repository on GitHub. So I can't tell you much about it other than what I've read. I was fascinated at its existence. But to me, the key was in any situation where you have existing Python code, but which you need somehow or other to get it to interact with something in the Java universe, that's where Jython is probably your best choice. Just looking to see if there are any other questions, anything else I can confuse you about or help you with. No, don't see anything here. There we go. There we go. I love that word perceived, right? We live in a world where it's all about perceptions. Shall we say a number of politicians in a number of countries have made outlandish statements because of what they perceived, what they believed. Well, that's not how the world works, right? The question is, why are you becoming a programmer? Are you becoming a programmer because that's your career choice, or as part of your PhD work, as part of your analysis in the finance department of your company, you need to do something that can only be accomplished with a little bit of code? Those are the kind of questions you're asking. If you want a career in software, then I believe Java is where you begin. You simply need to get something done and do not want to spend time acquiring a great deal of skill in coding. Then there's Python and a whole range of languages purposely designed to let people just get the job done and not worry about whether or not it's suitable to manage $1 million a week. Somebody's asked about lightweight IDEs and so on. I'm not quite sure what a lightweight IDE is. I think the closest was a few years in our program. We used a text editor called TextPad on the Windows environment. So if you're thinking of other ones with that name, this is something different that actually allowed you to execute the Java compiler from inside the editor. I guess that's about as simple as you can get. I think, though, with single file source code, it's now possible that anything becomes a lightweight IDE, even the dreaded VI. Some people have mentioned some lightweight stuff. I see things like JGrasp, JCreator, and I'm sure there are many more, right? Let's not forget, I'm trying to remember a name of a program that begins with the word blue, but it's lost somebody will remember it now. There are a lot of good things out there. What you want to be careful is they don't obscure the language so much that leaving that environment and going to the underlying language is like learning something all over again. And I can use one example, and maybe some of you have experienced it. It's called Alice. Alice is a really cool system developed. There it is, Blue Jay. Alice is a system that was created at MIT as a tool to allow children to code more easily. The problem is, it is so radically different, right? This drag, the images, that, leaving it and looking at what the underlying language really looks like, it's too much, as they say, like night and day. I have watched young children so we're talking about 9, 10. They do need to be able to read okay. I've watch young children write code, write Java. And of course, they don't suffer from the prejudices we all have from being, grown-ups. They just do it. And I think that's exciting. VS Code. Somebody's asked about that. It's cool. At last year's Code 1 in San Francisco, I was part of a presentation where we called it IDE Wars, and I actually presented NetBeans, which I'm fond of in the classroom, and I also presented VS Code. And what I wanted to demonstrate is taking even a complex source code example, Maven-based, that I use in my courses under NetBeans. I was able to review the code, execute, run just as easily in VS Code. And it comes back to something I have said before. I said earlier, IDEs are personal choices. You use an IDE because you perceive it makes you a better programmer. Maybe you use PyCharm for Python instead of writing at the command line. Whether you use Eclipse, IntelliJ. As far as I'm concerned, it doesn't matter what IDE you use. You use the one that makes you feel good. Just make sure there's Maven or Gradle behind it all. I'm just sitting here looking to see if there's any other questions or comments. No, I guess I also must be the last person for the stage because nobody else has come in. Bruno must be taking a nap somewhere, I'm sure. Let's see, what else can I talk about while we're sitting here? This is going to be my last year as a teacher. I've decided to retire at the end, so this would be 1 year from now, when hopefully I'm presenting again at International Career Day. I'll be described as Ken Fogel, retired teacher. And I hope in my retirement, I get to do more things like this. I have all kinds of things I'm hoping to do, travel, speak. The only thing that worries me about retirement is possibly not having enough money to buy myself more toys. But I'll figure something out. I'm sure somebody needs me for some lame little job that will let me buy some new piece of kit for my office here. And oh, by the way, the thing behind me is real. I get questions about that from time to time. Am I in front of a green screen? No, that's really my office, and that really is an @ symbol. Get my hands right over there. And there's Duke. This was awarded to the NetBeans team. Actually, Bruno, you were there when we received this. So it's spending some time in North America before it goes to its next visitor. I just love what I do. I have fun what I'm doing. I feel passionate about Java, but more importantly, I feel passionate about programming. Thanks.
Thanks a lot, Ken. It was awesome to have you here, man. This has been a great presentation. You're doing an awesome job at the JCP. So thanks very much for bringing this new energy and this new, this whole new thing about the education community into the JCP. We're really needing that, and so I'm very, very glad that you're pushing things around and asking hard questions and getting people to participate. So that's awesome. Thanks a lot, man.
Yeah. So everybody here has to go and join the JCP because I'm up for re-election.
Right.
September, okay. October. So everybody get out there, right?
Right. Yeah.
We need more old people on the JCP.
Yeah. Actually, Ken, we have we have a video that was recorded by Juggy, the Java Finch, that he teaches exactly how to join the JCP. Right. So it's a 5 minutes video that if you just follow Juggy, by the end of the 5 minutes, you're going to be a member of the JCP because he goes through all the steps, right? So anyone want to do this, so just look around for Juggy in the JCP, and you're going to find a video for him.
That's right. Pop over to jcp.org, join up, get access to information about the future of Java, where it's going. become a participant. That's what the JCP is about. Become part of the language.
Yeah. All right. Awesome, man. Awesome. So Ken, are you going to stay around here? Do you want a room to answer more questions, to talk to more people, or it's that enough for you? What do you want to do?
I can certainly move into a room, definitely.
Yeah, if you want to.
Yeah. How do you do that?
Because your room is available, right? So actually, maybe we can say. So maybe what we can do is we can ask for the team. Let me just kind of get here. So, you know, who is here in the room?
Well, I've got one question here that's just come up, and maybe I can just answer it quickly. It's
yeah, sure.
What short advice from your experience for teaching and breaking down concepts into understandable bits? I really wish I could give you, step 1, do this, step 2, do this, and so on. I believe in starting small and working out. I believe in the simplest approach. Complexity is something you try and avoid. You can't always. My teaching style in the classroom is, although you've seen a lot of PowerPoint here, my normal style is to work with source code, where we'll start and focus on a particular method in a class. We'll take a look at why it does what it does, and then start to move out and start seeing more and more of the picture. So that's the approach that I normally take in the classroom.
Awesome, man. That's awesome.
Okay. I think we're really done. People know where they can find me. Follow me on Twitter, OmniProf, OmniProf at Gmail, OmniProf at GitLab and GitHub. These slides are available there. I'm always somewhere.
Cool. All right, Ken. So awesome to have you here, and thanks a lot for this.
Cool.